Oh, hey there. Yeah, so I'm back. I guess I'd best get on with the presentation. So this talk is on real-time web apps in 2014 and beyond, and what I hope people will get from this is two things. If you've already used real-time web technologies and you kind of know what they're about, I hope it helps you come up with some new ideas of ways that you can use that technology. And if you weren't aware of real-time web technologies, real-time technologies, I hope to convince you of the benefit they provide and why you should be using them. So my name is Phil Legater. I work on a project called Blade Runner.js. Blade Runner.js is an open source web development toolkit that helps you build large, complex front-end HTML5 single-page apps. It's about workflow, it's about building modular applications. Nothing to do with real time. The company I work for, Kaplan Systems, help their customers build web trading platforms, such as this Kaplan Trader example. This is a relatively old app, but this is the sort of application we're talking about. As you can see, it's a complex HTML5 single page application, but it contains a lot of real-time data, and that's how I got into real-time technologies. So I've done this talk a number of times, probably about 20 times, in different variations over the years. So the first time I gave this talk was in San Francisco at HTML5 DevConf about 2 years ago. And since then, technology has moved on, as it does quite frequently, and things have changed. And whereas I used to speak about real-time web apps, I think it's best to now speak about real-time internet applications. So that's where we're going to focus. We're going to focus on the internet, because we've moved beyond just the World Wide Web, thinking about web browsers and thinking about documents interlinked by hypertext links. So we're thinking about the internet. So for this revamp of this talk, I thought I'd look into how the internet is being used in work-safe ways. So it was surprising. I didn't know that this crazy amount of usage was around 200 billion emails. I think that's absolutely crazy. This is per day, and 500 million tweets, 5 billion Google Plus ones. I didn't realize that Google Plus was that popular. It might not be, but certainly that plus one button is. 60 million Instagram photos posted. 200 million hours of YouTube watched each day. That's a hell of a lot of YouTube being watched, and a lot of time people are spending in front of that. So what I'm suggesting that this proves the internet is now the communications platform that we're all using, that the majority of people are using. I can't prove these facts, but those stats seem to suggest that there's a massive amount of usage there. And I think it's becoming the entertainment platform. So YouTube usage, Netflix, Amazon Prime Video, and so on, and the plethora of other on-demand services like iPlayer. So what I want to do is take that idea of the internet and build up this diagram, which shows the internet stripped down to its very raw TCP UDP, and build up that with components, with the things that we can use to try and reach to innovation. So that arrow kind of represents the work and the effort that we need to put in to really reach that point of innovation with the applications that we're building. So as you progress through this talk, I'll change that diagram so we're getting hopefully closer to that point of innovation and we're building amazing applications. So I want to address when we need real time, because we're here to talk about real time, and I want to demonstrate where it plays parts in some of these previous examples. And where really depends on, for me, two things. So the first thing is the data, and is there a timely nature to that data? Is there value in getting it quickly? And I think importantly, does it maintain context? So a terrible example is Twitter. So it's not that terrible. If somebody tweets, say there's a football match going on, there's Chelsea are playing somebody, and it's on Saturday and it's between 3 o'clock and 5 o'clock, and somebody tweets, "John Terry, get in." Now, during 3 o'clock and 5 o'clock on a Saturday, if somebody receives that text message, a notification that tweet's been sent, that makes a lot of sense. John Terry's playing football. the professional footballer John Terry, get in. Now, if that tweet is read or received at a different time, say a different event's going on, maybe John Terry's parking in a disabled zone, or he's verbally abusing somebody, or he's cheating on a teammate's, cheating with a teammate's partner, then John Terry get in completely or changes context in a very bad way. So the importance of when that data is generated and when it's delivered is very high. It's very important. Another example would be a Foursquare check-in. If you check in on Foursquare and somebody receives it because they're one of your friends, they go, oh, you're nearby. So there's a context of location. And then they reply quickly. The timely nature of that data matters. And you organise meeting up. There's an opportunity that comes out of that real-time nature of the data. The second thing to consider is the user experience that you're trying to provide, and is there a timely nature to that? So anything that's kind of human interaction, unfortunately we can't interact here because it's on video, but if it were chat, I could get feedback. If this was a live event, I could get feedback from you. If it's chat, if it's Skype, if it's anything that has an interactive nature to it, even if it's text chat, it can be quite frustrating if you don't get response relatively quickly. We've probably all had used Skype or Hangouts and had a high latency on a connection, and it becomes frustrating. So you need real time when it comes to those sorts of experiences. So I think we can boil it down to saying that real time is required when there's a need or demand for the two things. So up-to-date information and some form of interaction to maintain engagement in that application. And I would say that these aren't new needs or demands. They're things that have been around for a while. As human beings, we like interaction and we like being in the know. We like to have the latest information, and we like to interact with people and with systems. Games are very interactive, and any sort of interactive experiences. As human beings, we like those. So why haven't we done this sooner on the web, on the internet? Really because of a few things. HTTP, browsers and the servers, they just made it difficult. I want to address what was difficult about that. So HTTP tends to get a bad rep for this. It is a request response solution. It's a request response paradigm. You make a request for data. That data payload is generated and returned to you, and that connection is closed. And if you think about receiving data in real time, an event occurs, data should be delivered to you, a connection generally needs to be opened or open so that new data can be pushed along that existing connection. When it comes to browsers, specifically, maintaining those persistent connections was difficult. It was also difficult to do on the server. In order to do that from a web browser, we didn't really have any consistent way of doing it. The XML HTTP request object is around for making requests from JavaScript to the server, HTTP requests, but it wasn't available for quite a long time cross-browser. There's a 2 connection limit from a client to a server, and if you think about getting HTML, CSS, JavaScript, and also making these AJAX or HTTP calls, then that 2 connection limits eaten up quite quickly, especially when you think about opening multiple tabs. There wasn't a solution for cross domain requests, so I couldn't make requests in JavaScript from legator.co.uk to bbc.co.uk. You couldn't do that, so it kind of restricted how you could build these real-time solutions. And there were general browser incompatibilities. We've heard that a million times, and in terms of real-time technologies, that was certainly the case. So we're building up the stack. We've got a bit more. We can work with HTTP on top of TCP, UDP. But as developers, obviously, we want to reach that point of innovation, so we created hacks and tricks in order to try and reach that point of innovation and to generally innovate. We used Java applets and Flash as kind of an in-browser embedded proxy, because Flash and Java didn't have the same restrictions that the native browser and JavaScript provided, so you could make persistent connections from Java and Flash and make cross-origin requests from these things to servers. But unfortunately, we don't like plugins, as users don't like plugins generally. So we came up with a variety of HTTP hacks, and they were hacks because they provided solutions in different ways in different browsers. So it was very difficult to maintain these. But there were the hacks. So what were the driving forces behind these hacks? The first one is something that we probably won't be surprised to hear, is chat. So this is actually Talkomatic, which is a real-time chat solution back from 1973. So very old, probably on an intranet and not the internet, but it's still a real-time chat solution. Back in 2002, Yahoo had a solution which was also a Java applet by the looks of it, because it's got the ability to have sound and video, and the only way you would do that in a browser is through a Java applet. In finance, there was a demand for up-to-date information. So the previous chat examples are more interactive. In finance, it's more about receiving real-time data, or at this time, it's more about receiving real-time data, because the sooner you have that information, the sooner you can act upon it, and the sooner you can potentially make or save money. So this is Reuters 3000 Extra, I think it's also known as Cobra, a desktop solution. Now this is a web-based solution, and I think this is actually, I don't know, I found this online, it's a nice animated GIF, but I think actually each of these panes, although they're running in a browser, are actually Java solutions. So we were trying to take these desktop solutions to the web, because the web and internet, well, Explorer in this case, but web browsers were becoming ubiquitous, and it would make a lot of sense to remove the heavy desktop client that probably requires a license and an install, and move it to the web, where everybody has a web platform, a web solution, web browser solution. So that's kind of where we were going. And that's where Kaplan Systems, they had something called WebSheet back as early as 2001 to do this sort of thing. Oh, interrupted by a telephone call. That wouldn't happen during the real presentation. Okay, so yeah, Kaplan Systems were trying to create these solutions in the browser back in 2001. So clearly back then there was this demand for up-to-date information running in a web browser. So this is I'm talking about kind of 2001. So why has recently things gone, in terms of real-time, gone mainstream? The real-time web as a term and the technology. So I think, to put the answer very simply, I think we have to say social. And social has demonstrated this value. Solutions like Twitter and Facebook and Skype to a certain extent, we're starting to use these solutions a lot, and they're interactive communication platforms. If we think about them kind of fundamentally, they're about sharing information, but they're about building that interaction. They're about being in the know, having up-to-date information, and about building interactive experiences. There's loads of other chat solutions as well. So one of the key things I think about this is the idea of knowing who is interested in what information, so that instead of just being able to search and find information as soon as it becomes available, you can also have information that you're interested in pushed to you, and that's because of things like the follow button. We can follow, we can friend people. So the system, the application, knows the information that you're interested, so it can push it to you as soon as it becomes available. So that's the first fundamental thing. I'd say the second thing is that the technology around real time has become much more accessible than it used to be. It used to be that back in 2000, so Kaplan Systems, there was a company called Kazing as well, another company called Lightstreamer, that were kind of pushing this technology forward. They were doing that in a closed source way, because they were targeting finance. It was intellectual property as far as they were concerned. But the technology has become much more accessible. So I want to go into that a little bit more. I think generally servers are much more powerful than they were previously. So we've got the general benefits of that processors are cheaper, that memory is cheaper, that we can process data more quickly, that this connection problem that we had on the servers previously can be dealt with. We can hold open these persistent connections and deal with that in terms of resource usage. And we can also Scaling solutions in general are better understood, but also we have hosting now. We have virtual servers that we can spin up and deal with that scaling problem that we couldn't as easily previously. Web browsers have moved on leaps and bounds. I mean, the web browser is an amazing platform now for building our applications, and it's helped push the internet applications forward. We've got that XML HTTP request object that works in the same way across browsers. We've got cross-origin resource sharing, so we can make requests to different domains than the one that our application is running on. We've got specific solutions to real-time technologies, because it was demonstrated that we were trying to achieve things using real-time functionality. So W3C have listened and they've added some standards in place. So we've got server-sent events, which is the event source API built on top of HTTP. So an HTTP streaming solution. And we've got WebSocket, which is a single bidirectional connection between a client and server. Perfect for a lot of sort of interactive functionality. And we've got WebRTC, which a lot of people use for audio and video, peer-to-peer connectivity and functionality, but it can also be used for data. So we've got these three specifically real-time focused solutions. We don't need the hacks as much, but we actually do still need hacks for older browsers and for certain situations, and I'll kind of mention that shortly. The software choice has improved, so no matter the language or the runtime that your team or your company prefer, there will be a solution available to you. Open sourcing's played a big part of that, because it means that if there's a solution in a technology that you aren't that comfortable in, you can see how it's achieved in that and write your own. And generally the techniques to build real-time servers and real-time functionality have much improved and are generally kind of standardized now. And hosted services as well have made a massive leap in terms of making access to real-time technology possible. So we've now got all this kind of foundation for real-time functionality. I've been kind of talking about web browsers a lot, but because these are now standardized, HTTP obviously, the event source or server-sent events, WebSocket as both a protocol and an API, and WebRTC, it means that any client technology that can make a TCP connection can use these technologies. So we can have multiple devices of different runtimes talking to the same back-end service or peer-to-peer connectivity. I want to make a point on the connectivity. So when we talk about choosing a real-time solution with the internet or maybe web, even general web technologies in mind, your solution generally needs to have these. Ideally, it will create a WebSocket connection, but as I mentioned earlier, there are some problems where you can't create that WebSocket connection. Things like proxies get in the way or firewalls. So you need a solution that will do one of two things, that will try and make a WebSocket connection and will fall back through HTTP streaming, which is a persistent HTTP connection, HTTP long polling, which is opening and closing HTTP connections at long intervals, and standard HTTP polling. So you can fall back or you can upgrade. So if you do upgrade, you establish an HTTP polling connection and you try the next levels up to see if you can achieve that WebSocket connection. So the solution you choose, if you want it to work on all networks, then you need your solution to have to do that for you. So I want to talk about real-time web apps. We're about 18, 20 minutes in. So we're in a great place to innovate now. We've got that nice stack to build on, and the work we have to do to reach that point of innovation is definitely smaller. So what are people building with it? Now this is software. These are my opinions. So you can achieve the same kind of things in many different ways using software. So these ideas are just things that I've come up with. And so take it as my opinion. There will be other ways of doing it. So the first use case is simple notifications and signaling. So a couple of examples of this. So ITV about 2 years ago now, probably maybe even 3 years ago, updated their ITV News website to look like an activity stream. Now straight away that provides this feeling of being up to date. It's a live source of news. It's this activity stream of news. Secondly, they added real-time functionality, and the real-time functionality was as simple as soon as someone publishes content on their content management system, it's pushed to the browser and the user is given this notification which says, in this case, 4 new updates. Now that alone, when they clicked on that update, it would it would actually deliver the payload, and they could click on that update, and the data would be displayed. Now that alone, 2 years ago, or maybe a year ago now, increased traffic on the site by tenfold. So hopefully that demonstrates the value of just having a resource that's known for having up-to-date information and having a general feel. The second use case probably isn't as mainstream, but I wanted to provide an example of signaling. And obviously the Internet of Things is a big trend at the minute. So this is quite a good example of that. So this was from a hack event called, called Culture Hack Scotland last year.
He's got a really bad bug that he's been trying to squash for the last couple of days. He's struggling, and then eventually he comes across a solution, and then he wants to give a high five. He wants a high five from his team. So he then, go ahead.
I fixed it.
Woo, yeah! High five! So this is an internet-connected device. It's a social experience, and what actually happens is when he presses his red button, that goes off to America, and then comes back down to all of the connected devices, and then does a high five for everyone who's got one.
Okay, so silly, fun, interactive, but it's a really good example of just simple signaling. So there doesn't even need to really be a data payload. In the ITV example, there was the news payload, what news has occurred. In this one, it's just something which tells these two motors to move back and go forward, well, execute whatever it is that they're to do. It doesn't even need to tell them what to do. They do one simple thing. So a really simple example of signaling. The third example that I want to show is something called Talkie.io. So it's probably one of the best examples of using WebRTC. So WebRTC runs entirely in the web browser in this case. It's natively available in quite a lot of web browsers. Check out caniuse.com for full details. This is me talking to myself, one on my mobile phone and one in a browser. And the point of, so obviously there's the general peer-to-peer connectivity that takes place in order to transfer the audio and the video. But there's also still a need for signaling. And the signaling is used to tell one peer that another peer is available and wants to connect to it. Now, WebRTC doesn't come with that, so you need another signaling solution as part of that. Now, there are a few solutions available, but a real-time solution is obviously required for that sort of thing. So that's a really simple example. I'm not going to demo it. So in terms of the code for doing some sort of signaling, it's pretty simple. This is an example which uses something called Sock.js. Now Sock.js provides a WebSocket emulation layer. So the API looks like a WebSocket, but it deals with these HTTP fallbacks. So in this example, we're creating a connection from the client to this localhost 9999 Sock.js, and all we're doing is, this is the message. So on message, call this function whenever a message is received. On the server, we do some general setup. We require some libraries. We create our server. We say, our real-time server, we say hello.on, so there's some defined events. So when there's a connection, I get hold of this connection object, and I can do connection.write and send this message back. Down here, we just attach ourselves to a real HTTP server, which will also deal with WebSocket functionality, because there's an HTTP handshake that upgrades to a single TCP connection. So that's as simple as it is to do signaling. So there are a number of solutions when it comes to this, but interestingly, there aren't that many solutions, because what you'll generally find is there's a higher abstraction above this simple signaling, because when you build functionality, real-time functionality, you need more than just a simple signal. So going back to the ITV News example, they actually use Pusher, which provides more than simple signaling, and the High Five machine, Sid, who was doing the talking there, he used Sock.io for the connectivity, which offers more than just the standard signaling functionality. So here's a bunch of different solutions available. In fact, all of the client-server options are written in Node.js. Primus is actually an abstraction above the engine, so it can use SockJS or Engine.io. I should give webhooks a mention. So webhooks are a way of making HTTP requests. So an event occurs and an HTTP request is sent off to a registered endpoint with the data related to that event that occurs. So it's a nice way of getting kind of not just legacy systems, but anything that only really talks HTTP, and you want to use the standard HTTP request response paradigm to work. And then peer-to-peer, WebRTC isn't quite there yet. It's great, it's in a lot of browsers, but you probably need a library to do a little bit of abstraction for you. Simple WebRTC by And Yet, who also made Talkie.io, and peer.js are good solutions to look at. So our stack now looks like this. We've got that simple messaging on top of it. So let's move on. The next use case, I can't think of a better term, I'll just say lots of data. So what I mean by that is something like this, where we've got Manchester City's match day centre. And what we can do there is there's loads of different types of data, and you don't really want to be making a request and getting all that data back in a great big blob and then having to filter through it and find out where it, and grab hold of it and update different parts of the screen with it. You want ways of different parts of your functionality subscribing, there's a hint, to specific pieces of information in that application. So if we break up that UI, we can kind of say there's this top level part which has the overview information about the game, the score, who's playing, the players and so on. We've got this middle section which has some key events that are taking part in the game. We've got different activity streams of different types, commentary, key moments and so on. And we've also got this data down here about the starting 11 and information on that. So the idea here is that you can subscribe to specific parts of data. So in publish subscribe solutions, real-time solutions, these would be called channels or topics or subjects. So you can have a piece of functionality that subscribes to specifically the key moment, so maybe the overview information at the top, or maybe that subscribe another piece of functionality, a bit of code that's nice and isolated that subscribes to just this key moment information, and the same with activity streams. It's a really nice way of partitioning your data and a common paradigm that people are generally used to. If I can move on, yeah. So this is Kaplan Trader. So you've seen an example of this already. What I want to demonstrate here is that Kaplan Trader has a lot of complex functionality, as we've already seen. But not only that, it's a pub/sub solution. What happens is people change the data that they're viewing quite frequently. They can drag things around, they can scroll, they can change between tabs, they can look at different grids, they can scroll grids and so on. And what you don't really want to be doing is you don't want to be subscribing to all the data all the time. You only want to be subscribing to the data that you're viewing at that time. So publish subscribe works really well from that, because you can obviously subscribe to the data that you're viewing. When you're not viewing it anymore, you unsubscribe and you subscribe to the data you are seeing again. So I think that's an important use case for pub/sub. Simple example of that, this is using the Pusher API. I used to work for Pusher, so I think it's quite a nice API. Here you create a connection, you subscribe to, Pusher call it channels, other solutions call it topics or subjects. And once you've got hold of that channel, you can actually bind. So this is an additional abstraction which works quite well generally. So here I'm going to bind to, so the game overview is that top part maybe. Here I'm going to bind to the goal scored, so I can get a specific callback when a goal is scored, or I can bind to and update just the goal figures, and I can bind to the time updated, and I can just update that time section in the UI. And in terms of publishing, you just publish on that channel, you identify the event, and you supply the data. So it should be as simple as that. So the solutions that are available, there are a lot of publish subscribe solutions. I've picked out some here. Socket.io, obviously everyone's heard of that. It kind of goes straight for the evented solution. It does have an idea of in the URI you can identify kind of channels, but generally it's kind of an evented solution. But it's still kind of a pub/sub abstraction. Faye, which is in Node and and Ruby, and WebSockets by some guys in Sweden that I know who are really pushing this forward and really looking at the Internet of Things. It's definitely worth checking out. And there are a number of really good hosted solutions that offer pub sub functionality. I'll move on. So we've now got this pub sub on top of this stack. So our choices are even better now. The next scenario to think about is where the interaction, so we've really been talking about subscribing to data and really just receiving it. So publishing, subscribing, and receiving that data and dealing with it. But when I've been talking about interactive experiences, is there another solution in that sense? Because you could use PubSub and allow the client to publish, so anybody can publish on a channel. So that could be, you know, a client or a server or a device. But maybe there's kind of a specific client-server interactions. Now, this is a relatively new use. It's been around for quite a while. So it's something called remote method invocation, and it's been around for quite a while. It's been around in Java for quite a while, but I'm starting to see it appear in general real-time technology. So I want to try and provide an example of where it might be useful. Now, this is our FX motif, which is a foreign exchange solution. Now, when you open this ticket to execute a trade, the interactions between the client and server get quite complicated. So you open a trade, you get an open acknowledgement from the server. So you make a request to the server, send a message to the server, a message comes back saying that's opened. The server will maybe wait for that to be, in the client, sorry, you need to wait for it to be executable. The trade can then maybe be withdrawn, or it can expire, or you can execute it. If you execute it, you send another message over the wire. The trade is then confirmed by the server. There's then a confirm acknowledgement on top of that. Then the trade might expire. So, you know, there's a lot of complex back and forwards. And if you take that to channels and messages, it actually gets quite difficult to think about. But if you take that to an abstraction where you're making calls on an object and it just happens to be making calls over the wire, then remote method invocation seems to fit that quite well. It takes that complex messaging and abstracts and lets you just think about, as we do when we generally program, if we do object-oriented programming, about making calls on methods on objects and passing generally simple data payloads as parameters. Another good use case for this, I think, is gaming. So this is something called Shooter by SignalR, which is the Microsoft solution. Now, when you're building a game, you generally need some game state, and you need an authority for that game state. That can't be entirely in the browser because people can hack and change things. You need something running on the server which checks that game state. And the types of things that can happen in games are relatively quite complex. So it might be nice to have that rich semantic UI, API that you're calling on objects to represent, you know, player moves, firing rockets, teleporting, making calls to communicate with other ships and so on. So this might be another example where RMI is quite a good solution. So obviously SignalR, Shooter, this has been developed using SignalR. So here's an example of what the code for that looks like. Now the framework deals with taking this server code, this game hub, and creating a JavaScript proxy of that runs in the browser. They also have clients for Objective-C, probably not Swift yet, but C# and so on, and different clients that deal with this sort of functionality. So here we've got a game hub which extends something called hub, and it exposes a method called move that takes a player P and X and Y to see where it's going to go. Now on the client, we start the hub, which gives us access to a connection object where we can get this game hub from. So this game hub is actually a proxy to this game hub object on the server. Now from the server, from the client, we can call game.server.move, and you can pass me. Now here I don't really have a reference to me, but let's pretend that we do, and we can pass X and Y. And we're making a call in JavaScript. It just happens to be going over the wire. And then down here we receive it. On the server, we can then make our checks to say, okay, if this player moves from where it is at the minute in terms of state to over to X and Y where it's identifying, how does that affect game state should we allow that to occur. And then it can use this clients.all, which is part of the framework, to broadcast that message to all the other players to say, hey, this player has moved, and they can update their own state. What are the solutions available for that? To my knowledge, there's something called dnode, which, as you might expect, is available in Node, but I think it's also available in PHP and a number of different languages implementations of that. There's SignalR, which is the Microsoft solution, and then Java RMI, that's the namespace it's built into that. They're all self-hosted. I haven't seen a hosted solution yet, but I spoke to the guys behind SignalR, Damien Edwards and David Fowler, and they suggested that it might happen on Windows Azure with the SignalR, but it isn't something that's kind of pressing for them. So we build up the stack that we've got, and we're even closer to innovation. So the next thing I want to talk about is collaborating on data. So it's probably the best use case for this sort of technology at the minute, the one that I think will probably push us forward in using the technology most, and the one I've definitely seen. Some simple examples are things like Google Docs, where multiple people are collaborating on the same document together. We used to use Word, maybe check it out from SharePoint, make some edits, check it back in, wait for someone else to edit it after checking out and checking it back in again. We can now get a document in a reasonable state, all jump on together and collaborate on this document. It's also used quite frequently, this kind of idea, in kind of project management, agile boards, and online kind of code editors, IDEs, that let you edit code and run code together. And if you think about these solutions, what you're actually doing is you're manipulating a data structure, and you're sharing this data structure and manipulating that between multiple users. Another good use case for this is GIS, so Geographic Information Systems. This is something I created a while back for the ESRI challenge. I think it was 100 lines of code challenge, which was maybe a year and a bit ago, and won. So yeah, a really simple but very powerful example of that. Another really good example using GIS is this.
Hi, I'm Stephen Guerin. I'm a developer down in Santa Fe using Firebase for some of our applications in emergency management and new forms of human-computer interaction that lets people come around physical surfaces like a sand table or in an immersive room to communicate the effects of models in real-time events. Looking at what the firefighters will use as a common sandbox, they'll use very traditional medium of yarn to express the progression of a fire. We saw that initially as a primitive interface, but now we see that as actually something of a goal as a human-computer interaction to let people express models and interactions in that way, and we're now projecting digital information on top of that. The best part about using Firebase is I don't have to actually focus on the back end anymore. I can just publish some data and then give endpoints to other developers to subscribe to the data. And where we used to spend 50% of our development time building the back end, we can focus now 95% of our time on the actual application.
So that becomes a little bit of a Firebase pitch, but hopefully you can see a number of different things there. I really like the use of physical in combination with digital, and that the guy there talks about the fact that they used to think that interacting with a sand table was too primitive and a yarn of wool was too primitive, but they've realized that it works really well in terms of in these specific scenarios, and they're using a data synchronization platform so that no matter where you're located, you can be seeing the same view of that data. Now obviously it doesn't synchronize the sand that I'm aware of, but it synchronizes the data that's displayed on that sand. And I know for a fact that large organizations are looking at this sort of thing for kind of emergency scenarios where maybe multiple organizations, governments and so on might want to come together and have a full view of what's going on where, so that they can all act together and they can all collaborate on solving problems. So I think there's lots of use cases for this, specifically around GIS, but obviously elsewhere too. So this is the Firebase API, which is really, really simple. You create a reference to Firebase, and that's basically your data reference. In this case, I'm using it as a collection, and I'm just pushing on some data. Now, when I push that on, anybody that's bound to the child added event will have their function called. So you can bind to this child added, you can say when any of the children change, and you can say when any of the children remove. Now, there's more to the API than that, but just that alone gives you a lot of power. That alone allows you to build the Esri example that I provided before that lets you collaborate and add shapes to an application, to a GIS, to a map, sorry. So the solutions around data synchronization, there's two kind of, so Meteor and Derby.js are a kind of a new breed of application. They're an all-in, really. You need to be using their client and their server, but they do offer this real-time synchronization. They also offer HTML templating. In terms of hosted solutions and things that might maybe fit with other technologies, there's Firebase, who were given a mention there, and I'm wearing a top. I'm not affiliated to them in any way. Google Drive Real-Time API, which is used to power the Google Docs experiences, GoInstant, Realtime.co, and Simperium, who were actually about a year ago, maybe were definitely acquired by a company called Automatic, who are behind WordPress. And interestingly enough, WordPress also acquired the company that the guy that built Socket.io was CTO of. So they now have Socket.io, not directly, but they sponsor it, and Simperium. So we've now got this massive stack of solutions and ideas and ways of working towards innovation. And the point I'm trying to get across here is that it's so much easier now to innovate and use these solutions to add these really interesting, exciting, and productive experiences. So what I want to do now is talk about choosing a solution. There's lots of solutions available. How do you know which one fits? So a simple way of looking at this, it might not be perfect, it's just my opinion, is that if you don't have that much data in your application and the complexity of the real-time functionality in your application is simple, then a simple messaging solution with a simple payload is probably enough. As the data increases, the amount of data you've got, you maybe move up towards a pub/sub solution. As the real-time complexity, maybe client-server interactions, as they become more complex, then an RMI solution might be a good choice. And if you're talking about large amounts of data and it's all about manipulating those data collections, then data synchronization might be a good choice. Now, just to give you an idea, you can map some of the solutions that I'm aware of to that grid. So down the bottom left, we've still got simple messaging. We've got pub/sub top left, RMI bottom right, and data synchronization top right. So it's quite a good reference to be able to look at. So the final thing to think about is beyond. So where are we going from here? Now, the first thing I need to talk about is potentially a little bit negative. It's that the network infrastructure that we've got in a minute was built with HTTP in mind. It's not as reliable as it should be. As we probably know, messages get lost. It's not as fast as it should be when we're talking about real time. If the data is valuable and people want interactive experiences, then we need the speed of these networks to be really high. Going back to the HTTP point, we've got proxies that get in the way of different types of connections. We've got firewalls that do the same things. Now, if we are going to be using the internet continue to be using the internet as our communication platform, it needs to help us with these innovative technologies that we can use WebRTC no matter the network. We can access peer-to-peer on different ports than maybe a standard network, HTTP-based configured network would support. We're obviously going to have more things connected to this network, which is why we need these solutions. We need the network to be upgraded to sort and deal with this sort of stuff. So this study by IDC, which I think is part of Intel, they say we're around 2015, 15 billion devices. By 2020, they say that there will be 200 billion devices connected. Now that's 26 smart objects, as it says, per person, which is crazy, but not all that surprising if you think about the home, if you think about devices you carry on you, maybe multiple devices, if you think about our laptops and so on. I've got to give an example of probably the most common use case in Internet of Things, which is nodecopters. Now, nodecopters are doing a great job of getting people thinking about Internet of Things.
from Gangnam Style.
Crashed and burned. So it's a funny example, but I think it's a great example of where we're plugging two things together that we probably wouldn't have thought of before. We've got a dance mat from a PlayStation game or an Xbox game, and we've plugged that into controlling a nodecopter. Now, I think these AR drones are probably going to have use cases out of this. They have at the minute. You know, BBC are using them to control their video. I saw that on the BBC site. I know that they're being used in agriculture, and there's a massive demand for using them in agriculture. So they actually use UDP packets in this case, but there isn't a reason why they couldn't potentially use other forms of connectivity. But in terms of these UDP packets, if we're talking about the internet, you know, the internet needs to make sure that we're letting we have ports open, we allow these packets through. So that's a silly example, but it's true. And APIs. Now I've spoken about hosted services, and I haven't really spoken about APIs. A really good example of where these two things come together, Internet of Things, APIs, and real-time technologies, well, three things come together, is Nest. Now, I'm sure everyone's heard of Nest. They're acquired by Google for $3.2 billion. And they actually use the Firebase communication protocol as their API. Now, what that probably means, I don't know for sure, what that probably means is they've got a self-install of Firebase, and they're offering that as their API. This is a company purchased by Google for $3.2 billion. So Google are using a San Francisco startup-based protocol for powering one of their APIs. Now, that's massive to me anyway, being in this space. Other API providers that provide use real-time as part of their APIs. Now, obviously, companies like Pusher and PubNub and Firebase and Realtime.co and GoInstant and so on, they are standardly real-time APIs. But companies like SendGrid for email, MailChimp for email, Dropbox, who you probably saw as a synchronization platform, they've got, you know, real-time as part of their API for synchronizing data, but also for notifications about new files being created. Twilio for text messages and for phone calls, they've got real-time as part of their platform. So real-time is definitely part of APIs. And there are specific Internet of Things platforms, SmartThings, which are focusing very much kind of on home automation, NinjaBlocks, which seem to be concentrating on hackers and innovation. Everything I haven't really looked into all that much, but worth looking at. And Skynet IAM, which is very much a hacky Internet of Things solution. It's not a hacky solution, it's for hackers that want to do Internet of Things. And there's probably other solutions too. So the final thing I want to talk about is multi-device experiences. Now, hopefully that'll become clear what I mean by that. So the first example is something called Watchdogs. Now, I play my Xbox a little bit, not very often, maybe just when the new Grand Theft Auto game comes out. But I saw this recently, and what I really like about it is that somebody on console can be playing the main game, and they can be joined by someone on a smart device, a tablet or a handheld device of some other sort, who can play along with them and compete against them. Now, they're given a different view, but they're playing the game in real time. This is like a command and conquer view where they can drag around helicopters to try and stop the person on the main screen, on the main game, obtaining their objective, getting to their objective. So they can now explode gas pipes and change traffic lights, hack into traffic light systems, call out police vehicles and so on to intercept things that are going on. And I think this is more than just a second screen experience. This is seeing the understanding that we have multiple devices in our homes and we want to be using them in different ways for different experiences or part of the same experiences. This doesn't have to be just in the same home. This can be you playing on your iPad on the bus if you've got decent connectivity, while against somebody in the States somewhere. And I think tablets are really important because tablets are obviously exploding in terms of, or have exploded in terms of use. And the final example I want to give is from my mate Ben Foxall. If I can get over here and create a full screen. So Ben gave this talk at FutureJS that I was at. It's a really good talk. These are just two snippets from it.
So instead of moving the cursor and clicking stuff, I can just like press what I want to. And this so I can just touch the objects, which is a little bit more kind of closer to that interaction. Because the touch interface is combined with the screen, I can use that to put up a keyboard and I can like type stuff. And also we've got different interactions, like so we can touch and drag and like drag back down against and swipe to the side. We can do multi-screen interactions, so rotating stuff around, resizing things, and we can really kind of like physically interact with this device in a really kind of unique way that's very different from the way that you interact with a laptop. But I can add another device to this. So I've got this tablet here, so I can add this second device, and everything should rejiggle. And I can touch with this new device, but I can also still touch the old device. And what we've got is we've got a kind of like inter-device multi-touch gesture here. So yeah.
So I really like this example that Ben's provided. I think it's completely different to anything else that I've kind of seen. After this, he goes on about people talking, thinking about things in different ways. So thinking beyond the singular. We always think about a single device interacting, or maybe a second screen experience, but why do we have to be confined by that? Why can't we have multiple devices, different, they don't have to be touch, you know, multiple devices that are all using the internet as their communication platform and that allow us to achieve all these different types of experiences. So what sort of experiences would that result in? Over to you. So I think to summarize that the real-time internet apps are really the Internet of Things, because the Internet of Things are web browsers, they are web servers, they are native applications, they are devices, they are anything that can connect to the internet. That's key to me, and that's what I hope that the takeaway from today is, and that real-time technologies are what help you achieve those sorts of experiences. Thank you very much. I've got questions here. You could send me an email. Thanks very much. I'm Phil Legater. Feel free to drop me an email, phil@legater.co.uk. Thanks.